Hey everyone, today we're going to solve systems of equations, and this time we're going to use matrices. In the past, we've been able to graph two lines and find their point of intersection. We've been able to solve by substitution and by elimination. Using matrices is a new way to do it. So given the two equations that are on the screen, 2x plus 3y equals 4, and 5x plus 4y equals 17, we're going to set up the following in matrix form. Given that the first matrix, A, is the coefficients, X is the unknown matrix, and B is the solution matrix. So AX is equal to B. So again, in order, A, 2, 3, 5, and 4. X is the unknown matrix, X and Y. And B is the solution matrix, 4 and 17. Notice that the form is set up the exact same way every time. Notice that my equations were originally arranged in a way that I could put them directly into matrix form. Using what I already know, let's go through some of the steps. Find the determinant of A. Well, the determinant of A is 2 times 4 minus 3 times 5, which is 8 minus 15 minus 7 is my answer. Step 3 is to check the determinant. Is it equal to 0? No, it's not. That means I can find an inverse. So again, the determinant of A is not equal to 0. Therefore, an inverse exists. Next, I want to find the inverse. Well, A inverse is 1 over negative 7 times, switch A and D and change the signs in front of B and C. So my answer is 4 over negative 7, 3 over 7, 5 over 7, and negative 2 over 7. Fantastic. So these are all things that we've done before. Shouldn't be a problem for us. It says here, solve the unknown matrix now knowing what I have. Important, the order of the matrices is very important. So right now we have AX is equal to B. I want to get it to x equals. Now in order to quote-unquote get rid of matrix A, I'm going to multiply by its inverse. Because A inverse times A will give me the identity matrix. Well, if I multiply one side by A inverse, I have to multiply the other side by A inverse as well. Notice that on the left-hand side, I put the A inverse before the A, and notice on the right-hand side, I put the A inverse before the B. So this is very important. Wherever I put it on one side, I have to put it in the same spot on the other side. A inverse times A is the identity matrix. The identity matrix times any matrix is the matrix itself. So I times X is equal to X. So it's A inverse times B. Well, that's great. X is equal to A inverse. I have that. 4 over negative 7, 3 over 7, 5 over 7, and negative 2 over 7, times the B matrix, which is 4, 17. If I do the multiplying that I need to do, I'm going to come out with a 2 by 1 matrix. That 2 by 1 matrix is going to be 5 and negative 2. I can say this as well, xy is equal to 5, negative 2, or I can say x is equal to 5 and y is equal to negative 2. I can say it that way as well. Most students, when they're doing matrices, they prefer to say it this way. For the next example, we're going to do the exact same thing. I'm going to suggest that you try the example by yourself first, and then check to see if the work on the page is the same as the one you've done on yours. I also recommend that you have your graphing calculator ready so that you can check your work as you go along. So, here we go. AX is equal to B. A is 4, 2, 4, negative 1. X is xy. And B is negative 2, negative 11. Let's check the determinant of A to see if we can solve this matrix. Well, that's 4 times negative 1 minus 2 times 4, which is negative 4 minus 8, which is negative 12. Well, that's not equal to 0, so the inverse does exist. Well, A inverse is equal to 1 over negative 12. That's negative 1, 4, and negative 2, negative 4, which is equal to 1 over 12, 2 over 12, which is 1 over 6, 4 over 12, which is 1 over 3, and 4 over negative 12, which is negative a third. Now the step in between. If AX is equal to B, then in A verse AX is equal to A inverse B. A inverse times A is I, the identity matrix. The identity matrix times X is just X. So, X is equal to the inverse matrix 1 over 12, 1 over 6, 1 over 3, negative a third, times negative 2, negative 11. When I multiply, I should get out negative 2, 3 as my answer. If I wanted to do this entire question in my graphing calculator, I could. So walk through the steps with me. Second matrix here, I want to go over to edit matrix A. Matrix A is a 2 by 2 matrix. Its entries include 4, 2, 4, and negative 1. Oops, negative 1. Quit out of there. Second matrix, I want to put something into matrix B. Matrix B is a 2 by 1 matrix. Its entries include negative, whoops, sorry about that. Negative 2 and negative 11. Great. Quit out of there as well. Now, second matrix. I want this 2 by 2 matrix. I want to check the inverse of it, let's say. For example, that's great. It's in decimals. So math, frac, and there are my answers. Notice that this and the inverse that I have on my page are the exact same. That's great. I should check my determinant as well, in case you don't remember how to do that. Here's determinant. And again, it's second matrix. Whoops. Second matrix, it's A. So I can check the determinant of A if I want. It's right there. It's negative 12. So I've just verified that I could have taken the inverse. Now that I know that this is true, I can do the following. Second matrix, A. I can take the inverse. And I can multiply it by second matrix, B. And here's my answer. And I should get negative 2, 3, which is fantastic. Awesome.